Okay. All right, everybody, we are back on. Sorry for that.
Game on. All right, so the FizzBuzz example, I'm sure blew you away. But I wanted to look at some real examples. One of the fun things about the new Microsoft is that a lot of their code is now available on GitHub. And one of the fun things about pattern matching is that the open source revolution at Microsoft started before we had pattern matching. And so we can look at code from the Roslyn code base, the .NET Core code base, Entity Framework code base, ASP.NET MVC code base, and see how Microsoft is starting to embrace using pattern matching. And we can actually look at how it's being used in real production systems. I think this is actually a really interesting way to look at it. I had a lot of fun searching through their code and seeing what they're doing with it. So here is some code lifted right out of the Entity Framework Core code base. This is from the C# 6 version. Nice little method, kind of tight, pretty expressive. Nothing really wrong with it. We've got a null check, and with pattern matching, we now have a way that the null check can be removed. Now, to be fair, this method got longer, but that's because they added functionality to it. And so, basically, it is this first case statement is the main thing that is still there. They've added these other cases that they now have to handle. But where before we had to see if this was null, we don't have to check for null anymore. We just switch on the expression, and if the expression is null, it'll come down to this default where we return null. And after that, we can just handle this with our default logic. Here's another example that comes out of the EF Core code base. And this actually is C# 7 code already. What I wanted to show here was just an example of where they're using guards to remove the necessity of having nested if statements. So each one of these case statements matches on a type, and then the guard is actually calling another method. It's calling the isEntityQueryable method. And so if the type matches and isEntityQueryable returns true, then we'll fall into that case. But instead of having 4 nested if statements here, we can just do it all right in line with the guards. Makes it a lot nicer. One of the other things I wanted to show here was that the matched variable that has the type from the match can be used in the guard. So we don't actually have to wait until this entire case statement has been evaluated before using it. If the type matches, we can use it in the guard right away. And so if isEntityQueryable is false, we wouldn't execute this block. We would go on and check the rest of them. But we can use that strongly typed variable immediately. Here's another sample from C# 7. It's out of the EF Core code base. And here we're matching on 4 different types. And if the result operator is one of those 4 types, then we will call the transform expressions method. But the thing that I want to point out here is there's actually a new operator that's new in C# 7. It's that guy. And if you look closely, it's blue because it's actually now a reserved keyword. That's, in pattern matching, this is the discard operator. You could also think of it as the I don't care operator. Normally in pattern matching, we're going to match on a type, and if this matches, we'll assign a variable. What if we don't care about the variable? What if we just want to check the type and then do something? This, the discard operator just says, you know, it's fine, I don't need it. I don't want to have to create a variable for it. The discard operator isn't limited to pattern matching. You can actually use it in other places. For example, if you had a try parse where you just want to know if the string parsed, but you didn't actually care about the output, you can use the discard operator as that second variable to try parse, so you don't have to assign a variable that you're never going to use. No, so if the type of the result operator variable is exception result operator, cat result operator, or these other two, then this will execute. We just don't have a strongly typed variable because in this case they don't need it, so we're just throwing it away.
So are you saying like if it matches all of those, it's kind of like a flow through?
No, any of them. So yeah, so this behavior of the case statements is exactly the way that case statements worked in C# 6 and before.
Like 1 through 3.
Yeah, so you could have had 1, 2, and 3, and if they're stacked together like that, it would match on any of them. Right. And it's that behavior of the switch in the case statements is the same. So yeah, if it matches any of these, it will execute that block. It's worth noting that this introduces a slight change to C#, because before C# 7, the underscore was actually a valid identifier. If you wanted to have a variable named underscore, you could do that. If you wanted to have a function named underscore, you could do that. If you did that, I'm sorry. It's one of the, it's a classic example of just because you can doesn't mean you should. Like if you actually have a method named underscore, hopefully you have teammates that will code review that and find that very funny, and then force you to change it. The only legitimate example I've ever seen of having an underscore is in the Fake It Easy library. Have you guys ever used Fake It Easy? No Fake It Easy users? Oh, man. So in the Fake It Easy library, you are mocking objects, and there is a case where you want to mock a parameter and you don't care what it is, and so they have a property that is the underscore, and it actually continues to work because, where did I put that code? If you're one of those people that really want to have an underscore, oh, there it is. Guess what? Microsoft is actually going to continue to allow you to have an underscore as a variable name. So if you have an underscore as a variable name, that will continue to be valid. You can see here that I'm assigning underscore to 42. Come on. Here's some code where, like I said, I'm going to try parse on a string S, and all I care about is the Boolean result, and I want to discard the output variable. So it's kind of nice. I don't have to declare a variable and then not use it. What's interesting is that if I have a variable named with the underscore, which is, like I said, a valid thing to do, I will now get a compiler exception. Oh, it's an int. That's what we're trying to parse. Let's see. Let's say I'm assigning 42 as an integer. That continues to be valid because basically I'm now assigning the result from the try parse into this variable named underscore. Whereas if that's commented out, I guess the highlight doesn't change. It's now the discard operator. I was trying to see if it was or not. I don't think it is. That's kind of disappointing. If I have a variable of type string, also named underscore, this is now a compiler error because it can't convert from out string to out int. I think that's the red squig. It's the red squiggly you're seeing. All right, so that was a very long explanation of, yes, you can still make really bad decisions with your variable names. That's all you're going to remember. I'm going to teach you everything you want to know about pattern matching, and you're like, sweet, I can't wait to get back to the office tomorrow and have a function named underscore. It's going to be awesome. Here's some code that is lifted out of the ASP.NET Core MVC code base. And in this case, we're matching on a class attribute. And the thing that's notable here are that we are both going to match on an HTML string and HTML content. A couple things that are worth noting. I haven't showed code before where you can match on an interface, but you can do that. What makes this code interesting is that HTML string implements HTML content. And so technically a variable of a variable whose type was HTML string could match both of these. So this introduces a new nuance in C# where the order of the case statements is important. In C# 1 through 6, the order wasn't important, but it never had to be because you're always either matching on a string or an integer, and you weren't allowed to have two of the same. Because conceivably a variable could match on both of these cases, the order is now meaningful. So if a variable is of type HTML string, it'll match this case, execute this block, and break, and go on. You won't double dip and get both of them. You'll match on the first one, and then you just go on. If these were switched, we would always match on HTML content, and then this would never execute. If you really care about the details of languages, it's worth noting that while the order is important, the default is always evaluated last. So that's kind of like the asterisk. But order is now important, and you can match on interfaces. No, it is the order that they appear in the file. Now, here's some code. And this is actually the code we looked at the top of the hour. It's from the Roslyn code base, and we're trying to figure out the type of a node in the abstract syntax tree. And what we have is a set of 3 as casts, and then we're going to check for null in the result of that cast. So if the node variable is not an expression syntax, we will call as. This will be null, and so this block will not execute. And they'll do a similar thing with the statement syntax, you know, have the as cast, check for null. Global statement syntax, same thing. With pattern matching, we can shrink that down a lot, because like I said, one of the things pattern matching does really well is check the type and do a strongly typed assignment. So this is like this code example is like the honeypot of pattern matching, because now I don't have to have an as cast to see if it's the right type. I just have a case which will check the type and do the assignment, and I can still have these same blocks. This type of code is perfect for pattern matching, and also eliminates a whole bunch of null checks. Like I said, if node is null, none of these will match, and we'll just, in this case, you know, fall down to the return. Here is another bit of code out of the Roslyn code base, where we're going to have an is check, and then use the conditional operator to use one of two examples. With pattern matching, we can now say, we can do a similar thing, but we don't have to have that cast. You can see here, you know, we can check if expression is expression syntax, but then we have to cast it to an expression syntax before we can do anything with it. With pattern matching, I can say node is expression syntax expression, and I don't have to have that secondary cast. There's something else noteworthy about this code and why I want to show it to you, and that's that this code does not use a switch statement. This is the other form of pattern matching. Most pattern matching uses a switch statement. We also have this pattern that we can use after an is. So I can say node is expression syntax, and it will populate this variable if the result of is true. Right? So pattern matching mostly uses a switch statement, does not exclusively use the switch statement. One last code example from the Roslyn code base. Here we're switching on an enumeration. And that's not very interesting because we could have switched on an enumeration since the beginning of C#. But what's, oops, that was not what I wanted. What's noteworthy about this is that we're using a guard clause with an enumeration. We talked about guard clauses as being how we have some additional evaluation after the type check. We can have that additional evaluation after any case statement. So we're not using pattern matching here, but we are using the guard. Yes. So we could have a case of syntax kind dot greater than token without the guard. So we could have like another one of these that might be evaluated if this evaluated to false. Good question. Yeah. I would hope it would yell at you. So like, now let's just try it. Let's say that let's say object O equals null. Compiler might not like this. I could switch. What? Oh, so I don't even need to do that. So let's switch on O. Case of string S. What's that complaining about? And then if we, let's just try that. Yeah, so switch case has already been handled by a previous expression. But I bet if I did this and said s.when s.length is greater than 30. What? All right, so it turns out you do have to be a good programmer.
Some of the functional languages, when they do that kind of pattern match, you're doing on an enumerated value, what tell you is you haven't covered every enumeration.
Oh man, you mean like if we were in F sharp?
Like F sharp, for instance, yeah.
Oh man, hey, I'll give you your $5 later. Let's look at some F sharp. Okay, we'll come back to F sharp. Yeah.
I just had a question about the breaks. I noticed some of them didn't have the breaks, and some of them, you had it after
So that's similar to how C# has worked up until this point. So in C# 1 through 6, you could stack case statements, and as long as you didn't try and do any evaluation between them, it would basically match any of them. But then, like,
but you've never been able to stack case statements without breaks. Case 1 equals
right, and you still can't.
But you do have some places in there where there's an apples in between. I've seen some of them.
Let's come back to that afterwards. We can look through those samples again, but
so we can probably eliminate that right now if you pointed it out.
Oh yeah, because you can have returns without breaks. Yeah, if you return, you don't have a break. Actually, if you try and do a return and a break, it will yell at you because that you have a line that's unreachable. Yeah. Yeah. Right. You mean like if yeah, yeah, already been covered. Interesting question though. Yeah. Just one. You can only ask one. Nope. All right, now we're moving on. So you can still have, basically your guard clause has to evaluate to a Boolean. Right. So yeah. Yeah, so I mean you can, in the same way that you can combine Boolean statements in an if statement, so yeah, you could use the AND operator because that entire expression would still result in a single Boolean value. Yeah. So what I did was I cloned all the repos that I wanted to search on my local machine. And then I wrote a little application that uses the Roslyn SDK and basically compiled them. Or I guess I didn't go all the way to the compilation process. But I used the Roslyn compiler to parse all of those applications. So like I would just parse all of Entity Framework Core. And then the Roslyn SDK has a method called getDescendantsOfType. And so then I would just search for descendants of type guard or descendants of type pattern. So I use the Roslyn SDK to search for pattern matching and the different forms of pattern matching. Good question, though. So I could do varq, which would match anything. Yeah, it's so the example I was showing earlier with the tuples works a little bit better because it can resolve the variable to something better than object. I mean, I could do something like that. Default still works, so I can say. So one thing you can do, let's say I have a variable up here, bool Brian asks questions equals true. Let's see. I could use that variable here, so I could say s when Brian asks too many questions. So my guard can use any variable that's in scope, not just the match variable. I don't know if I can. Oops, that was not what I wanted. Come on. Yeah, it looks like I can't put a when on a default, which kind of makes sense because if it's the default, then it would just default to everything. Yeah, then you would have to do the var would be what you want, because you could do. I could change this. Mm. Oh, now it's mad at me because I'm not doing anything. Yeah. Yeah. So I can still have, I could have a case of null if I wanted to. I can still have a default. Yeah.
Can you do both a type check and just a value check? So at the very first case, before your first case, could you do case and then a static string? Like case quote XYZ?
Let's see. O would have to be a string, right? Yeah, so I could say case of the. Oh, maybe it doesn't. Yeah, apparently. Yeah, we're gonna go down kind of a deep rabbit hole here. How about this? Once we get through some of the other content, if people want to hang around and like try crazy pattern matching stuff till midnight, we can write some really terrible code together, and that'll be a lot of fun. We'll just see what happens. But first, let's talk about some other languages. I brought this up a couple times. Pattern matching is new in C# to C# and C#7, but pattern matching itself is a fairly old construct. If you've done functional languages before, then you might have seen this. I kind of fell in love with pattern matching for the first time I ever played with F#. And here's a tip. If you see a presentation from someone that has 2 F# stickers on their laptop, you know you're going to get some F#. You know how you know if someone's an F# developer? Don't worry, they'll tell you. Oops, that's C#. So in F#, we have a slightly different syntax where we're actually going to use a match keyword. I got to read an explanation one time of why C# didn't implement a match keyword, because there are some times when match would actually make more sense. But in the same way that having an underscore kind of changes the syntax and makes some valid variable names not so valid, if they make match a keyword, then they would basically invalidate every variable, class, and function named match. So they didn't want to do that, because they want to maintain backwards compatibility. But in F#, I can match on I. And in this case, I'm going to have cases for 0, 1, 2, and 3. And the underscore is similar to the discard operator, but it's a default. The syntax here basically is the match keyword, and as long as we have that pipe going, we're still inside the match operator. And so we have the case here, and then we have an arrow, and whatever's on the right side of that arrow is what we're going to return. Now this is the feature that was brought up earlier. And then I can also match on discriminated unions, which discriminated unions are kind of like a more powerful version of enumerations. And so I can match color, and if it's red, I'm going to return red in Spanish, blue in Spanish. Yeah. But if I add another discriminated union here, I will now get a warning that's going to tell me that I have an incomplete pattern match on this expression. And it's going to go so far as to say, for example, the value green may indicate a case that is not covered. This is a really powerful feature for large code bases. In this case, it's really obvious that I have green here and not here. But if you were working in a code base that had 100 or 1,000 source files, or if you were working in a code base where maybe the enumeration was defined in a NuGet package, and a new enumeration was added, all of a sudden you have pattern matches that aren't complete. And so to allow your compiler to tell you, hey, I've got an issue here. There's a new enumeration that's not covered. Let's go ahead and cover that. That's a really nice little feature. If you've worked with F# at all, you will know that F# tries really hard to see the entire universe as a list. Doesn't matter what it is, it wants to treat it as a list. And so it makes sense that F# and the other functional languages have really nice pattern matching on lists. something that's very common nomenclature in all functional languages is to be able to think of a list as a head and a tail, the head being the first item in the list, and the rest of the list being the tail. And so I can pattern match on the items in the list, including the head and the tail. So let's say I have a function here called does list start with 42, and I'm going to pass in a list called myList. I'm going to match on that list, and I can say if this pattern basically tells me that if the head is 42, and I'm not going to check anything with the tail, but if the head is 42, I'm going to return yes. Otherwise, I'm going to return no. So I'm actually pattern matching on the contents of the list. Yeah.
You can have an empty tail, fine. It would still matter.
Don't you have to have tail so it knows it's a? I think you have to have tail to know it's a list.
Oh no! I thought he meant 42 with an empty tail.
Oh yeah. So yeah. So one of the things that's worth noting is that the tail could be like if you only had a list with 42. Technically, there is a tail that is the empty list. Kind of strange if you've never seen it before. But yeah. All right. Here's another example where I'm going to match on the content of a list in a very oversimplified method that looks to see if we're looking at a list of Fibonacci numbers or primes. And so you can see I can actually check a whole string of hard-coded values and then the tail. There is also the ability to, again, use the underscore to say I don't care. So in this first pattern, I'm just going to say I don't care, I don't care, I don't care, and then check 3, 5, 8, and 13. And then for primes, I'm actually going to look at everything, and it's just if neither of those match, then we'll default to no. One place where this is really nice is when we're checking the input parameters. So in the same way that C# will pass you an array of arguments, F# does the same thing if we're passing arguments in from the command line. And so I'm going to convert my array of arguments to a list just because it makes it easier to match on. And so then I can match on whether or not the user passed in -help. I could do something with that. If they pass in -v, I'll print the version. If they pass in -greet and a name, then we'll print line hello and then use the name. So we actually have the ability to decompose the list and pick out a variable and use it. We're not matching on the name. Basically, any string will match that. We're just going to populate that variable and then use it in the resulting expression. So I'm just scratching the surface of what F# can do. And I would really encourage you to go check it out yourself. F# is a beautiful language. One of the things that I'm not going to go into tonight is something that F# has called active patterns, which is where you can actually write your own ways to match on things. So like if you wanted to have a custom match operator, you could absolutely do that. But that's beyond the scope of what C# programmers need to know about pattern matching. How many of you guys have seen the language Rust? So if you haven't, Rust is a very new programming language that was developed by some people inside Mozilla because they wanted to rewrite part of Firefox in a way that was faster. And so they've rewritten some of the core pieces, and they're actually out now. So if you saw any of the news, the press releases about some of the speed improvements in the last 2 versions of Firefox, it's because some of these pieces that they've rewritten are finally done. But they wanted to have a really modern language that was still very low level and very performant. But they did opt to put in some of these newer language constructs like pattern matching. So this is one of them. This is one of the ways that you can match on things. On line 1, I'm declaring a method, or excuse me, a function called getLetterGrade. I'm going to pass in a grade. That is a 32-bit integer. That's what the I32 means. And I'm going to match on the grade. And what this syntax means, these ... is it declares a range. And so this pattern will match on any integer in the range between 90 and 100. This range here will match on anything between 80 and 89. I don't have to do the greater than or equal to and less than or equal to 89. I can just match right on the range. So this is pretty exciting. It's a neat little feature. And the best news is that since the first time I gave this talk, this is now a C# 7.3 proposal. And when I say it's a proposal, I mean this may or may not be in the language. You can actually go to this GitHub URL and follow the progress. There is a small amount of controversy on this. If you were going to write this code, show of hands, would you expect this to match on 0 and 10? Show of hands. Yeah.
I would expect my stress to have inclusive and exclusive.
All right. This is no small debate right now. So Rust, which I just showed, actually has 2 versions. And I am not a Rust, I don't remember enough Rust to remember. 2 dots, I think, is exclusive, and 3 is, 2 dots is one and 3 dots is the other.
Wouldn't they need like 4 versions? Exclusive, less exclusive, I'll roll your own code.
This is why there's currently an argument. If you can find the issue for this, there's a lengthy debate on that specific thing. Again, I don't really know John Skeet, but I had that picture. This is one of the things I ask him about. Like, hey John, I'm doing this presentation on pattern matching. What can you tell me about this? And it's funny how this is like the one thing that C# programmers want to fight about. But it's a thing. I'm sure that this is a feature that will make it into the language in some form. It might eventually have like a 2 dot and 3 dot thing. Yeah, who knows? They might come up with some other syntax. But ranges are a big thing. They're coming to C# sometime. How many of you guys have written code in Swift? Few people? Have you done much with the pattern matching in Swift? Quite a bit? So you know about this feature? This is a cool feature. I love this. Swift has basically all of the same pattern matching features that C# has. They've also had them since the beginning of the language, but they baked in another one that I'm really fond of. In Swift, you can pattern match inside of your for statement. So let's say we have an array of optional ints, which if you've never done Swift before, optional ints are kind of like nullable ints. You have a variable that could either be an integer or null, except in Swift, instead of saying null, we say nil. So technically, we want to check for non-nil values. And what we're going to do is we're going to say for case let number question mark in array of optional ints print found a and then the number. What that question mark does is it pattern matches on non-nil values. So I don't have to have a nil check anywhere else or a null check. If I run this code, it will print out found a 2, found a 3, found a 5, and skip over the 2 nils. In my decade as a C# developer, I have written a lot of code where I looped over something, and the first statement was like, if this is null, next. Or maybe in a link area, I would say, for each something in collection where f is not equal to null, or something like that. But to be able to do it with just a question mark is pretty slick. I like that a lot. I kind of doubt it. It'd be one of those things that would be a big enough change that they'd have to do it in some really weird way, or break backward compatibility, and it would break back. They won't break backward compatibility. It'd be cool if they did. Actually, if they did, probably if they brought it to C#, I'd be up here like, I can't believe they did this. It's terrible. I don't know. I just wanted to show it because there are a lot of things about what some of these other languages do that are slowly making their way into C#. Like you said. Yeah. So you could pick out just the types you want. Yeah. Nice. The reason I think it's important for C# developers to know what these other languages can do is, as you pointed out, C# and Microsoft more broadly are, kind of good at copying things and absorbing it into their languages. So even if that syntax doesn't make it into C#, there might be a concept like that that does. How many of you guys have ever looked at Elixir? It's funny how it's like the same people. Elixir is a fascinating language, and if you have only ever written C# code, Elixir will mess with your head, but in a good way. Like it'll take you a minute, and then you'll see things that you've never seen before. It's great. As a total side note, I really think you should go check out Elixir. It's a fascinating language with a great ecosystem, and you'd be better off for it, even if you're not going to use it in production. Elixir is also a language that kind of is a thought experiment of like, hey, let's pattern match all the things. And they put pattern matching in all kinds of crazy stuff. But this is one of the big ones. So when I first saw this feature, I described it as overloading a method based on a pattern. But I actually got some help from a guy named Nate Taylor, which Nate Taylor wrote a Pluralsight course called Getting Started with Elixir. And he corrected me. He said it's not a method overload. It is a multi-clause function. But if you're a C# developer, it looks like an overload, because it looks like I have two overloaded definitions of first. And what this method does is it will return the first item in a list, and both of these are accepting a list, except this one will get called if the list is empty, and this one will get called if there is a head and a tail. If the list is empty, this one will get called, will return nil. If the list is not empty, we'll match on this definition of first and return the head. So while in C#, when we overload a method, the methods have to have different signatures. They have to have different groups of parameters that you pass to them, right? Different parameter types that you pass in. In Elixir, these both are accepting the same type. It's just that we're actually inspecting the value here. And so we're picking which one of these method bodies we're going to execute based on the values that are passed in. And it's not just the structure. We could actually check actual values. So we might have a method that looks like, or multi-clause function that looks like this, where we have 3 implementations of list type, and we're just going to inspect the first 3 or 4 items. If it's 1, 3, and 5, we'll call the version of the method that returns odds. If it's 2, 3, and 5, we'll return the string primes. And then 1, 2, 3, and 5 will return Fibonacci. So this is really interesting, really powerful stuff where we can actually call different functions based on this. And you could imagine more interesting examples where we're doing something in a function that's much more sophisticated than just returning a string. If you want to learn more about Elixir and you have a Pluralsight subscription, I absolutely recommend Nate Taylor's presentation or his course on Elixir. If you want to do something slightly different, Rob Connery has some really great content on Elixir that is like part ebook, part exercises, and like you have code that you download and manipulate. It's actually pretty cool stuff. So I recommend both of those resources pretty strongly. Another variation on what you can do with multi-clause functions is you can use this do syntax, which puts them all in line. And so technically here you have 3 method bodies, but you actually just have 3 different lines. So you can start to do some really slick, very tight code in Elixir. So that's all well and good. I have hopefully showed you some really powerful things that pattern matching can do. But if you're going to take anything away from this, you have to start recognizing when you can use pattern matching. You have to start to be able to match the patterns of when you should use pattern matching. So if you have code, you're trying to figure out when to use pattern matching, ask yourself these questions. I guess they're not questions. Think of these statements. When you have different behaviors based on the type of an input variable, consider using pattern matching with the type pattern. So we have that switch statement, switch on the type. When you have a case statement with nested if blocks, consider rewriting the if blocks to be guards. Use that when statement, put your Boolean expression in the when. You can remove the if and the brackets around it. When you have an is check immediately followed by an as cast, consider using an is statement with pattern matching. I showed that slide where you can use pattern matching without the switch. You just have the is and then the type pattern to populate the variable. When you have an as cast followed by a null check, consider using the is statement with pattern matching. It's a related concept where we can match on the pattern, and because the null won't match, that'll just fall through. So you don't have to have that null check there, and it'll totally be safe. There are other times when I'm sure you could find ways to use pattern matching. In my experience, these are the places where it comes up the most. If you have other situations where you're starting to use pattern matching a lot and you have an addition to this list, please, please, please find me on Twitter or somewhere and tell me, because I would love to add to this list. So why should you care? You've been sitting here for a while listening to not John Skeet talk. You're like, oh man, I don't know if I care about this. I think you should. I hope you care. Because here's the thing. We now have this language construct that combines selection, assignment, and evaluation and mashes it into one feature. We can write safer code. We can write less code. We can write more expressive code. These are all core values that we care about in the source that we write day in and day out. So pattern matching helps you in a lot of ways. Thanks for letting me come up here tonight. If you want to hang around and try other really bad things with pattern matching, I would love to do that. If you have Other questions? The easiest way to find me is on Twitter. I am at PotterEric. All the code you saw tonight, all the C# and F# code that you saw tonight is on my GitHub account. Also, PotterEric is there. I have blogged about pattern matching. If you go to humbletoolsmith.com and look for the pattern matching tag, you can see all the stuff I've written. Some of it will look really familiar because a lot of it is in this presentation, but there's more detailed explanations there as well. With that being said, I hope you got something out of this. Let's chat afterwards, and thanks for coming out, guys. So you're right. One of the things that is true is when you have different types, when you want to have functionality based on different types, you could put that functionality in the different base classes. One of the reasons I started with that WPF example was for a reason. Sometimes you don't control those types, right? If you're switching on something that's coming out of WPF or ASP.NET, you might not have the ability to inject functionality up there. In those cases, you have to use pattern matching. After that, user discretion. Because I know I don't have a satisfactory answer for it. I have sat around and yacked about it with a lot of people. It's cool that there are other questions. I think we need to get out of here.
You're good. I was counting people. You take all the time you need. Take an hour. We're good.
I'm not going to take an hour. Yeah, question over here.
Question, can you pattern match your IList and switch them on different types just for different?
Like, could I switch on a list of string or a list of int or a list of control? Mm-hmm. Yeah, and you can match on any type. So, yeah. I think there's a question over here.
Yeah, I remember you were calling a method with the brain stuff.
Mm-hmm.
So can you call your own custom method?
Oh, yeah. So
if they have some kind of side effect, then
So if you call call a function with side effects in a guard clause, don't do that. Yeah. So keep in mind, the guard clause only has to be an expression that results in a Boolean. If you want to do something bad, you can.
but some languages don't allow you to do that.
Right. In the functional languages where you have far fewer side effects, you couldn't do that. C#, yeah.
Elixirs, when clauses will not let you use anything that will have a side effect. It's a limited subset of the language that you can use.
Yeah. But in the functional languages in general, it's kind of baked in that they have much better constructs for eliminating side effects than C# has. So, yes, you could write bad code. You have to be a good programmer. Good question. All right. Yeah. So it kind of depends. You're not the first person to ask me that, and I have tried to find an answer. Do you guys know who Bill Wagner is? Bill Wagner's on the C# design committee. I asked him that exact question, and his answer was there probably is a performance implication if you measure it down to each CPU cycle. He said it's never going to matter. There's nothing about pattern matching that's going to introduce a performance problem that's ever going to be your problem. It's probably a couple CPU cycles different here or there, but basically he told me it was a dumb question. I'm like, thanks, Bill. I love you too.
Worrying about pattern matching, going down your code correctly is premature optimization.
Yeah, there are other things. There are other language features that have bigger performance implications, especially around link, but pattern matching isn't one of them. All right, guys. Offer still stands. I'll hang around and write code afterwards if anyone has further questions. Other than that, I'm going to turn it over to this guy.
I just wanted to say where's Waldo?
All right. He's right here.
You coming to the bar, right?
Yeah.
Thanks so much. Big round of applause for Eric.
Don't live stream the last bit.
Yeah. If we left it on last time, I would have accidentally given away like bank account numbers because I'm bad at this. Everybody say buy stream on 3. 1, 2, 3.